Hi guys. I'd like to talk this morning a little bit with you guys about sizing gas pipe systems. And what I did was I made up a little outline that identifies some of the requirements, and I'm going to kind of chunk this up. I'll talk a little bit about the factors for starters, and then I'll look at, we'll move on into the general sizing considerations as well. So kind of chunk it up a little bit. You can do it in bits and pieces. So the first thing that I would like to identify in sizing a piping system is really my first goal, and the primary goal that I want to try to make sure that I do in my sizing is I really want to make sure that I can get kind of what I would call the required inlet pressure to every appliance. So in other words, I have it highlighted. So the gas pressure to that inlet to that appliance has to be appropriate, has to be correct. It has to be sufficient. So that's kind of one thing on there. The majority of my systems being residential, they generally have almost all the same requirements. It's really unusual to see appliances that would have other inlet pressure requirements that are varied by much more than maybe an inch of water column. And I'll do an example here coming up here shortly. So part of that, let me go back to this. So in your lecture materials, you're going to have a typical install gas piping, and it'll look a little bit like this. So in this particular setup, what we're looking at here is an application where the utility is going to supply, they're going to supply gas and a high pressure gas line here. They're going to make their way up and they're going to enter a service regulator. That service regulator is really just going to drop that pressure down to some usable pressure, which is going to be really what's going through the gas meter. So the gas meter, so technically where this regulator is technically where my point of delivery is. So I'll be mentioning that on future lectures. Now, as we go through the gas meter, and there is a requirement that we come out of the gas meter, enter the particular building with a 1-inch gas line. That is actually a minimum requirement. There are some applications where you'll have to come in even bigger than that. So if they have a high consumption rate and they didn't go to a high pressure system, they're going to need to do that. So as I venture on and mosey on, you'll notice that I have a main piping system that they have a main piping system that's going to kind of feed all of those appliances, and they're going to tee it off and they'll bring it down to every one of these appliances. And we've got to make sure that we can feed sufficient fuel with a reasonable or a minimal amount of pressure loss in those lines, that it's not going to choke these appliances down, and that really will create some problems on there. So that's the first thing. All right, so back to the outline. So I had mentioned on here the typical minimum requirement for pressure to the appliance inlet is normally going to be about 5 inches of water column. So you might notice this on a tag on the appliance, and I'll likely have one of your assignments is going to be for you to identify that. So I'll likely take a picture of that and I'll pop it in the blackboard, and you guys can identify exactly what the minimum inlet pressure is for 2 applications. And so if we take a look at this, your operation of the appliance regulator, typically I have to have enough pressure, maybe 4.5, 5 inches of water column, which is normal. And I've got to now bring that pressure through the appliance gas valve, which will then drop it down to a manifold pressure. And that manifold pressure could be anywhere from 3.5 inches as kind of the typical, on a single stage appliance, or it could even be, I've had them where they've been 4 inches, I've had them where they've been 3, I've had them where they've been 2 inches of water column. It really varies by the appliance, but the norm that we would typically see is usually around that 3.5 inches of water column, and I have that right here. I'm going to highlight that one right here at 3.5 inches. And that's going to be the minimum pressure drop that has to be subtracted from that source delivery pressure to verify that minimum is available to the appliance. So I'm going to go back to that picture now. Let's see what this means. So for example, if this appliance or this gas meter is supplying fuel at, let's say that you're going to supply fuel here at 7 inches of water column, which is kind of the normal gas pressure coming out of the meter. And if I basically size this entire system, and let's say that this appliance here needs to have 5 inches of water column going to it, well, I've got essentially about 2 inches of water column to work with. And as long as I can have a system that isn't going to tax that, or I'm going to reduce it or choke it down too much, I shouldn't have any problems doing that. Most of the time when I'm sizing a system, I'll use a pressure drop of roughly about 0.5 inches of water column is typical what I use. And so technically for me, that means if I leave at 7 and I go to my worst case appliance at the longest run, I'm probably going to end up with about 6.5 inches of water column in the worst case scenario if I do it right. So that's kind of a little bit of a quick example of how that might be done. All right, so let me go back to the outline. So a little bit on that. So specifically, I do want to chat a little bit with you guys about on the inlet pressures to different appliances and how that could vary significantly. You really have to be careful on applications where you might have an appliance that you are completely unfamiliar with, and it could be it could be that a customer has a fire pit outside or something where they need to have a higher pressure to make the fire pit even work. So you have to kind of watch that a little bit on there. So if there's something unique, then you might want to look further into it. So typically, most of the time, if I look at an application, the main thing that I probably need to be looking at is what is the greatest inlet pressure required to be satisfied. So, and I need to make sure that I feed enough gas to that unit that I do not go below that minimum inlet pressure that is needed for this one. Otherwise, I'm going to run into problems with that. So I want to go back to the diagram. So if I had a situation where this water heater happened, let's say that this water heater was some unique water heater that needed, the manufacturer said you must have 8 inches of water column into that appliance. Now, of course, the first thing that I would see is my inlet pressure being 8 inches and my normal gas utility supplying me fuel pressure at 7 inches. Right away, that would raise some red flags. That would probably tell me that I would need to be looking at doing something different for a fuel supply system. So in other words, I might need to say, hey, gas company, you guys are going to have to give me a 2 psi regulator, or you might have to give me a 14-inch regulator, and depending on what they have available to them and what they will allow you to do that. But you have to kind of work with them to identify what is the requirement that you have for your system. Again, really unusual. Most of the time this is not a problem. I wouldn't anticipate 8 inches. In fact, unless it's a commercial job, I would say most of the time you're going to be okay. So typically, like I said, this appliance might say, hey, it wants 5 inches of water column as an inlet. This one might say it needs 4.5 inches. This boiler might say that it needs 6 inches of water column as the inlet pressure. You just have to figure that out by simply checking at looking at the requirements for each of those appliances on a job site. So a lot of guys, on a job, they're not even going to look at those things because it's not typical that you would see that. So I even put a note in there that in this handout that the factor, as far as it would be seldom that you would ever really see that where they want a source that's significantly different on there. So I don't anticipate that a lot of the time. So just keep an eye on that. Just something to pay attention to. I've had commercially, I've had this happen on some jobs where they want a much higher requirement. but there I was dealing with a hybrid system with multiple reductions. So anyways, moving on. So in summary, obviously, I want you to recognize that all of your appliances have to be supplied with a minimum amount of gas pressure that's going to allow that unit to operate correctly, to give you the right amount of fuel to the inlet of that appliance. Generally, the farthest appliance and the appliance with the highest demands have to be met. So in other words, usually we kind of call that a longest length or a longest run. So the one that has probably the most restrictions is the one that you have to do, and you also have to make sure that you have the demands that are met as well. And again, I made a note of that. I said, you know, when you're dealing with new appliances, when you're dealing with these sorry about that. When you're dealing with those new appliances and you're not really familiar with them, make sure you are looking at that minimum inlet pressure that they need for their consumption. So good place to start. All right. I'm going to stop the recording now, and I'll do the next one as another little mini